the students. Okay, recording now. Okay, noted. I'm going to ask the students to actually share with me among all the topics, which one is it they could not understand. Okay, so I share with you the, wait, I just get the link. The link, 1 minute. Where is my link? Yeah. Wait 1 minute. What is that thing? A chat. Oh, I'm looking for chat. Okay, I'll share with you the Menti link. Maybe you can start responding and tell me which are the topics that you need me to elaborate more so that we can actually assist. You can start giving your feedback, students. We have 42 online. Did you get the link? I am sharing this one now. Okay, simplification. Some more. Good. The rest, so that we can do more on that particular topic. You know, things like that. Only one student. The rest understand everything. Very good. Huh? The rest, everything okay, yeah? Everything. Okay. All. Some more? I give you another 1 minute for you to respond. Because today we are going to share logic gates, Boolean algebra, circuits, you know, simplification and K-map, yeah? So Boolean algebra and K-map will proceed with circuit simplification. So we want to know which one is it that you would like to be elaborated more, yeah, for further clarification so that you can understand the detail. Okay, so that's it. I think we are good with that. I'm going to start now. Okay, the notes. Okay, so anytime that you anytime that you can't see my slide, please let me know. Okay, so or you can't hear me, please unmute and tell me, yeah, because just in case if the internet is not so good, etc. Yeah. Okay. For the first one, what are logic gates? Okay, because every time when we are given a subject or a course to study, we need to ask ourselves, yeah, why do we need to learn all these subjects? What will it do? Why we need how is it relevant, or how is it related to the scope of degree that we are doing, and what can it leads to? Why do we need to understand the fundamental of it? Okay, always ask that to ourselves, just not because, you know, we are in the electrical engineering or electronics engineering and we are given this subject, so we go for it and we study and we need to understand. Always ask that why. We need to have that curiosity to ask so that we know what is the purpose of each subject that we are given to and why we need to learn. Okay, so the first one you will ask, okay, what are logic gates? Okay, so logic gates actually are the fundamental when it comes to digital system. The next thing that you need to ask is, what is digital system and how is it differ from the normal maybe electronics, electrical? Okay, so digital system is something that involve digital. So what are digitals? It's either 0, 1, things like that. Yeah, it is a decision by two situations. Okay, so to perform all this, we need the logical operations. Yeah, For example, where do we actually use logical operations 0 and 1? And then you start relates it to your everyday life. So one of it very near to us is the switch on and off. Okay, that's the first one. Where else? Our lamp off. Okay, light off. Okay, where else? Traffic lights. Where else? You start asking yourself. Okay, so those are logical circuits. So what are the blocks or maybe the components that can perform these logical operations? So I presume that you have go through the fundamental of logic gates, but we are going to actually share again. Okay, so logic gates, there are 7. Okay, we are going to go through briefly today. Okay, whichever that you could not understand, we will go more. So what does this logic gates do? Okay, so remember, all logic gates, they have only one output because they are digital, right? 0 and 1. However, the inputs, it can be 2 or more, but that depends on the gates. Okay, some gates, they have only one, which is inverter. Inverter can only have 1 gates. Okay, sorry, 1 input, sorry. And XOR, XNOR, there are also the beauty of it. Okay, they have 2 inputs as well. So like AND, NAND, OR, okay, NOR, they have more than that. They can have 2 or more inputs, but all logic gates, all 7, they have only 1 output. Okay, so remember that. So this, I'm not going to read from the slides. You can have the slides later on. Okay, I will share with your professor and they will pass it to you. So now what I want you to do is get involved and actually start compiling what you want to know more, so that we can actually I can actually help to clarify whichever that you don't really not so that you don't, not to say you don't understand at all, but you need more elaborations, yeah, we will say. So these are all the things that I have mentioned indirectly, yeah. So what how is it actually in digital system that it represents the 0 and 1? How does it from the voltage, okay, it goes to the circuit, okay, or the gates, okay, and how does it represent the 0 and 1? Yeah, so there are many names we call it. We call it on and off, we call it as low and high, okay, we call it as high and low. We normally call high and low, or on and off, or things like that. Yeah, so when it goes to 0, it's totally off, which means that is represented by the voltage that represent the 0 is 0 volt, which means it's ground. However, for it to be 1, logic 1, it is actually represented minimum by a 5 volt, okay, value. In between 0 to 5 volt, okay, it can lead to invalidity. It can sometimes go to 0 or 1, so we don't want the voltage to be around that area. Anything above 0 or below 5. Okay, so how do we know? Shall we connect it to 5 volt, 6 volt, 7 volt, or 8 volt? Those are actually written, okay, because these gates are in which is in IC, integrated circuit, yeah? We call it chips. Okay, it can be 8, normally it's 8 pin. Okay, I'll share some diagram with you later on. So each integrated circuit, IC, they have their information sheet, yeah, that you can actually determine from there what are the value for it to represent as logic 1. Connect it to 5 volt, or maybe 7 volt, some IC, or maybe 8 volt. Normally it could not be higher than for digital system, yeah, for logic gates, it should not be higher than 12, if I'm not mistaken. It should be between 5 to 12. That depends on the design, yeah. Okay, so all that, okay, you need to know. Okay, now you understand what is logic gates. Okay, what is it doing? How can we get logic gates around us from the IC? How do we want to know how to connect it to perform maybe a project or something that you want it to do, okay, is through integrated circuits, yeah, which is we call it as IC. So when we build our circuit, how do we check it? There's two ways that you can check it. One, you use multimeter and check for the voltage drop, I mean the voltage measurement. The other one, you can use oscilloscope and you look at the waveform, because the digital waveform will represent if it's 0, yeah, which is low, and vice versa. If it's somewhere at high, it will show what is actually, maybe it's 5 volt, maybe 4.8, everything is acceptable. 4.5 above is acceptable, but nothing less than 4. Okay, so if we see, there are terms that you need to understand when you read books, when you search the internet. There are terms that you need to know. Besides low and high, there are also terms that we call as, because all this that you need to know the terms when we go to flip-flop, things like that, designing of analog to digital converter, yeah. So the terms is actually here. When it goes from low to high, we call it the rising or leading edge, because it's going up. So dia naik lah, rise kan, dia rise ataupun dia lead. Itu term dia. So when it says leading, rising or leading, is going from low to high, 0 to 1. Okay, when it goes down from high to low, it's known as falling or trailing edge. Okay, so those terms, okay, the standard terms is called positive going pulse, negative going pulse. If it's going from high to low, is negative going. If it is from low to high, positive going, because logically it's going to 0 to 1, so it's positively going up and vice versa, dan sebaliknya. Okay? Okay, ini saya dah cerita juga, ya. So saya dah cerita, saya tak payahlah baca slides ya, because saya telah share with you what is it. Okay, so every logic gates, okay, they have one thing that we need to know, or we need to actually understand, or that represent the logical of the gate. It is actually the, what is it? The truth tables. So what is truth table? What is it telling us? Truth table is showing the relationship between the inputs, okay, and the output. Okay, so which means if it's one input, like inverter, very easy. One input, it can be either 0 or 1. Remember, we are going for logic, which is digital. Digital is either 0 or 1. So inverter is either the input is 0, okay, or the input is 1. That is, we have one input. If we have two inputs, okay, we will have four possible combination of inputs. So the truth table will be a 4 row that is telling if the inputs is 0, 0, 0, 1, 1, 0, 1, 1, what will be the output. So truth table is actually telling us the relationship during that inputs, okay, combination of inputs, what are the output. So how do we know how many inputs actually is possible to be combined? That is again the rule, remember, 2 to the power of n, where n is actually the number of inputs. So if we have one input, 2 to the power of 1 will give us two inputs, two possible combination of inputs. If we have two inputs, we have 2 to the power of 2, 4 possible. If we have 3 inputs, 2 to the power of 3 will be 8 possible combination of inputs. So your truth table combination of inputs at the input side depends on the number of inputs of the logic gates. And how do you know how many? Is 2 to the power of n. Okay, remember that, 2 to the power of n. That's how we know how many possible combinations of inputs. So it starts with 0. If it's 8, everything starts with 0. So it starts with 0, 1, 2, 3, 4, 5, 6, 7. Okay, it is represented in binary. Remember, this is digital. We only handle 0 and 1. Okay, so far so good, yeah. So every logic gate, it has a logic symbol, 3 things. It has a logic symbol, logic equation, and truth table. we need to know. Kita kena kenal lah kan logic gates ni. Macam mana nak kenal? Adalah satu simbolnya, kedua equationnya, ketiga truth table-nya. These three informations or these three things are the fundamental that we need to know when it comes to digital logic gates. Okay, so ask yourself, which part that you still not clear? Okay, setiap logic gates we need to understand the logic symbol, how does it look like? Symbol to how does it look like? Yeah, the equation, okay, and the truth table. Okay. I recap aja. Okay, I rasa semua dah tahu ni, tapi saya ulang lagi. Okay, the first one is inverter ataupun sometimes dikenali sebagai NOT gate. Why not? Because dia invert. Invert kan, dia songsangkan. Kalau inputnya kosong, dia jadikannya satu dan sebaliknya. Kalau inputnya satu, dia jadikannya kosong. Okay, that is NOT or inverter. The first one. Okay, the second one is AND gate. AND gate ni seperti multiplication. Darab ya, darab ya. Kita panggil di sini dipanggil darab. Darab ni asal ada satu kosong, kita dapat jawapan kosong kan, contohnya. So here AND gate, okay, if any of the input or inputs, kalau three inputs ya, any of the input 0, the output definitely 0. Nanti saya akan share truth table later on. Tapi ni saya just recap balik. Okay, so X, Y ni mana-mana 0 dia akan jadi 0. Begitu juga di sini, ya. X, Y, Z ni asal 1 0, outputnya 0. Okay, so but we don't say X multiply by Y. How do we say it when it comes to digital? We say X and Y, X and Y and Z. Okay, that's how we actually mention it. Okay, okay. Or pula, it's something like adding. Tapi bukanlah add 1 plus 1, tak adalah begitu ya. So, how do we say it? As long as one of the input is logic 1, high, the output will be 1. As long as 1. So, we call it X or Y. Kalau dua-dua tu satu, 1 or 1. 1 or 1 is 1. Okay, that's how we say it. Yeah. And NAND ni pula adalah invert of N. Bila tadi NAND ni, okay, bila N ni asal ada satu saja input 0, outputnya akan 0. So NAND ni pula adalah sebaliknya. Okay, kita akan kata not N. Okay, NAND is actually the from the word asal not N. So dia akan opposite of whatever N is doing, AND gate is doing. Okay, so remember that. And similarly, no, it's actually not OR. So it is doing opposite whatever an OR gate is doing. Okay, so you have 1, 2, 3, 4, 5, yeah. Okay, and there are two beauty gates, which is very unique, that can only have two inputs, which is, we call it by the name pun ada nama dia, exclusive OR, exclusive NOR. Okay, so we will see how the equation is. I think you pun dah tahu macam mana equation dia, but these two last gates, which is exclusive OR and exclusive NOR, okay, it is actually specifically for certain design of situation that we are going to use this gate. Ya, nanti kita tengok kat mana kita guna. Well, so remember I mentioned earlier, every logic gates, we need to have three things about it, which is the symbol, the truth table, and the logic equation. Yeah, so these are the, mana lagi satu? Okay. So these are for this is for inverter. Sorry, this is for inverter. Remember, inverter, it has only one input. Yeah, so 2 to the power of 1, we will have two combination of inputs, which is here, and it is inverting. So when it's 0, when it's low, it's giving a high output, dan sebaliknya. Kalau outputnya 1, dia akan bagi opposite, which is 0. So simbolnya adalah X is equal to A bar. Bar tu menunjukkan dia invert, not X, not input. So opposite of that. Yeah, this is the symbol. So this is a logic symbol. this is the truth table, this is the logic equation. Remember, 3 things that we need to know for every digital gates. Ya, bukan setakat the 7 ni. Nanti bila kita buat simplification pun, we need to have these 3. Ya, kalau tak macam tak cukup lah syarat dia kan. Okay, ini dari segi waveform yang memaklumkan macam mana kan. Remember, kalau kita tengok di scope, okay, kalau dia opposite of that, so anything that input dia adalah high, outputnya adalah sebaliknya because it is inverting ya. Untuk yang yang sini. Okay, that's the first gate. Okay, the second gate that we actually mentioned just now adalah AND gate. And remember how do we pronounce it? Dia adalah A and B. A and B. Dan asal salah satu input tu adalah kosong, outputnya akan kosong. Remember? It's similarly something like multiplication, tapi kita tak mention A multiplies by B. We don't say that in digital logic circuit, yeah, logic gates. We call by the name A and B. And how do we know it has 4 possible inputs? Again, 2 to the power of 2, which is 4. And it starts with 0. So 0, 1, 2, 3. Cuma ianya dalam binary. Ya, saya rasa by now you dah tahu macam mana nak convert dalam bentuk binary kan. So these are the output. Remember, as long as one of the input 0, the output will be 0, except the last one, because 1 and 1 is 1. Okay, so senang nak ingat AND gate ni, okay, akan jadi high bila semua inputnya adalah 1. Okay, all inputs are high, only AND gate will have a high input. So tak kisahlah 2 input ke, 3 inputs ke, 4 inputs ke, you tak payah susah payah nak cari kalau AND gates ni, asal semua inputsnya high, the output will be high. Selainnya, asal satu je kosong, output dia kosong. That's how actually you cepatkan you punya, how shall I say, nanti bila you nak buat simplification. So these small things, okay, we need to grasp. Yeah, we need to grasp and understand so we can speed up at the simplification. Lepas ni kita akan tengok logic simplification which comprise of several gates, you know. Bila kita buat design dan sebagainya, bukan 1-2 gate kan, kita akan guna maybe many gates, ya. There are ways that we can simplify it, maybe use Boolean algebra or you use Carnot map. Okay, ada 2 cara kita akan tengok mana yang you selesa dan you faham, ya. Itu kalau you do your own projects, tapi when it comes to examination, sometimes we want the students to understand, so we actually put the in the questions that this one you use K-map, this one you use simplification. Okay, so dua-dua kena faham lah sebelum you decide mana satu you nak guna. Okay, kita nak you tahu semua. Okay, so the AND operations di sini dia kata macam mana kita nak tengok adalah selalu kita pakai dot tau. X dot B, tapi kita pronounce sebagai A and B. Itu kalau very basic lah, tapi lama-lama nanti kita dah tak pakai dot tu dah. A, B, C tu kita faham lah, A and B and C. A plus B plus C kita panggil A or B or C. Okay, those are the things on how the way that we write the equations, ya. So untuk N ni kalau you tengok sini mula-mula ni dot lah, tapi lama-lama kita pakai macam ni pun okay. Kita dah tak pakai dot dah, ya. Remember, AND gate only will be high when all the inputs are high. Very easy to remember, ya. And the logic equations di sini, A and B. Okay, the third, this dari segi waveform. Jadi, bila nak tengok waveform ni senang je. Bila dua-dua high, dekat situlah dia high. Selainnya, you tak payah tengok. So, nanti bila you buat flip-flops, you know, you banyak nak buat kan ADC, flip-flops lah actually, register dan sebagainya. Kalau ada gate-gate ni, you tengok kalau it involve AND gate, bila you tengok waveform tu high, kat situ je you draw high. Selainnya, flat 0. Okay? Kecuali dia ada combine dengan yang lain lah. This is I'm telling the basic of it, ya. Okay, this is OR gate. That's the symbol. Okay, that's the truth table. Remember, OR gate asal salah satu input satu, dia akan satu. Dia macam adding, ya. 1, 0, A or B. So any of A, any one. Sama ada A adalah satu atau B adalah satu, outputnya adalah akan menjadi satu, ya. And that's the logic equation, the logic equation of OR gate. Okay, and remember, bila waveform senang je nak ingat, asal salah satu aja A atau B tu high, dekat situlah kita high kan. So sini akan jadi high. Okay, sini pun high sebab ni semua dia jadi high sebab salah satu je high. Okey, sini pun dia akan high sebab B high kan. Cuma dekat sini sikit dia akan 0. Okey. Lagi mana yang ada dua-dua 0? Sini 0. Okey, dan di sini sedikit 0. Selainnya dia akan high. Okey, begitu. Kan? Sebab ini adalah OR gate. So, tak payahlah you nak tengok, every macam tu kan. That's how kita speed up kita punya nanti analysis, ya. We call it. Okay, NAND gate. NAND gate is not N. So, dia opposite daripada N lah. Kalau N tadi, asal salah satu input kosong, dia jadi kosong. Sekarang, NAND gate. Asal salah satu input kosong, dia akan jadi 1. Dan bila dua-dua, 1 dia akan jadi kosong. Dia terbalik daripada N lah. Okay, so that's how the truth table are. And this is the logic symbol. Dia ada AND gate, cuma dia ada bubble kat situ. To inform that it is inverting N, not N. Okay, dia ada bubble depan situ. Okay, and this is actually the logic equation. Kita how do we pronounce it? A and B. No, A and B bar. Okay, kat sini kita cakap A and B bar. So bila ada bar tu, okay, it is telling we need is inverting. Okay, di sini kita panggil not N. Not tu di represent, cara di represent adalah dengan bubble. So this is actually not N. Dia berfungsi opposite of AND gate. Okay, and we have ini bagaimana kita tengok. So kalau dia berfungsi opposite of AND gate, mana-mana kosong, asal salah satu kosong, okay, ataupun senang you nak tengok mana-mana dua-dua high, dia akan jadi 1. So sini dia akan jadi 1. Selain daripada tu, minta maaf, bila dua-dua high dia akan jadi kosong sebab dia NAND gate, ya. So you tengok mana yang dua-dua high, you low kan. Selain daripada tu dia akan high. Because it is opposite of your AND gate. Okay, I hope everybody is good. Ini tak apa, question ni nanti kita tengok. Sebab kita boleh, ada juga combination of gates that can perform as inverter. Nanti kita akan tengok lepas ni bagaimana, ya. Saya dah bagi jawapan pun kat situ. Begini. How would we connect a 2-input NAND gate to perform a basic inverter? Caranya adalah you combinekan kedua-dua input menjadi 1 dan dia akan jadi inverter. Okay, that's the answer to it. The next one adalah not OR, NOR gate. Okay, so dia opposite of your OR gate. Kalau OR gate tadi asal salah satu dia akan menjadi 1. Sekarang asal salah satu dia akan menjadi kosong sebab dia terbalik. And again, remember the bubble that represents it, ya. Yeah? So dia akan menjadi 1 hanya pada satu keadaan bila kedua-duanya adalah kosong. Okay, so that is the NOR of it. And how do we read this? A or B bar, the opposite of that, ya. Yeah? And remember, dia akan jadi 1 hanya bila kedua-dua kosong. So you carilah selain daripada tu mana kedua-dua kosong. Sini ada sikit, sini sikit, sini ya. Dan the last one. Selain daripada tu dia akan jadi, dia akan jadi kosong. Mana dua-dua kosong baru dia jadi 1. Okay. So this is one application of LED is on for the circuit shown using NOR gate. Okay. The LED will be on when any of the 4 inputs are high. Sebab this is NOR gate. Okay. Soalannya bila LED tu akan on? Dia akan on untuk connection begini asal salah satu input tu adalah high. Okay, dia akan on. Sebab salah satu input high dia akan jadi 0 dan bila invert dia akan jadi 1. And this is common and not. Okay. XOR gate pula. Ini the beauty of XOR gate. X or exclusive OR kita panggil. Macam mana you nak tahu dia exclusive OR? Dia ada sini tau. Dia punya sini the drawings of dekat inputs tu dia ada one more additional situ. That's how it indicates the exclusive OR dengan exclusive NOR. Yeah. Okay. So XOR gate ni dia tak ada XOR gate juga dia tidak ada input lebih daripada 2. Dia hanya ada 2 input dan 1 output. So the XOR gates ni dia akan produce high hanya bila inputs adalah opposite of the logic levels. Maknanya sama ada kedua-dua kosong atau kedua-dua 1. Salah satunya adalah 1. Sorry. The XOR gates produce a high output only when both inputs are at opposite level. Opposite level maknanya sama ada, tak samalah dia opposite. Maknanya bila kedua-dua kosong atau kedua-dua 1, dia bukan opposite level tu you punya inputs. So dia akan kosong. Okay, so the equations adalah A B bar or A bar and B. And this is how we write it as exclusive OR gate. Ya, A dia macam A or B tapi dia ada round kat situ to indicate it is an XOR gate. Okay? So these 7 gates kita kena kenal lah kan, macam kita kena tahulah barulah kita akan proceed dengan design dan sebagainya ya. Remember XOR gate macam apa syarat dia? Dia akan jadi high bila input tak sama. Senang nak cakap macam tu. Bila opposite level maknanya input tak sama. Kalau input tu sama, maknanya 220 atau 221 XOR gate akan jadi low. Okay. So bila input tak sama dekat mana? Tak sama bila salah satu kosong lah. Salah dekat sini lah. Kosong, ni 10 sini yang mana yang ditandakan dengan kuning tu. Itu bila input tak sama. Sama ada 10 atau 01. So dekat situ dia akan jadi high. Selainnya dia akan jadi low. Okay? Okay. Okay, dia kata if the A and B waveforms are both inverted for the above waveform, how is the output affected? Okay, maknanya kalau kedua-dua waveform ni kita terbalik kan, songsangkan, bagaimana outputnya? Dia tak ada change lah kan? Sebab syaratnya adalah kalau sini mula-mula 220 sekarang jadi 1, outputnya inputnya masih sama nilai. So bila 01 dia jadi 10 pun masih sama nilai. So dia tidak akan ada perubahan pada output. You can try this later. Okay, the next one, the 7th one, remember kita ada 7 gate tau. The 7th one adalah X NOR, okay, exclusive NOR. Again, how do we know? Because of the representative of this curve here, and it has a bubble to indicate not XOR. So kita panggil dia X NOR. Okay, X NOR ni terbaliklah daripada XOR. Kalau kita tengok tadi XOR, okay, ini XOR gate kita. XOR ni bila input tak sama nilai dia akan jadi 1. So X NOR dia terbalik daripada tu. Bila input sama nilai dia akan jadi 1. Selainnya jadi kosong. So input sama nilai ni maknanya bila both 0 or both 1. Okay. So untuk X NOR, exclusive NOR, itulah the opposite of it. Ya, bila input sama nilai maknanya bila kedua-dua 0 atau kedua-dua 1, the output will be high. The rest the output adalah 0. Okay. And the equations adalah begini, A or X or B bar to indicate it is an X NOR gate. And the waveforms, kita cari mana input sama nilai. Maknanya kedua-duanya kosong atau kedua-duanya 1. Okay, di sini seperti indicate dengan yellow ni. Okay, and there is where the output will be 1. Selainnya output adalah 0. Okay, so those are the shortcut things that you need to actually grasp ya, supaya senang nanti bila you dah faham tu, senang you nak buat analisis seterusnya. Okay. If the A waveform is inverted but remains the same, ni dia lain sikit. A saja invert dan B remains the same, how is the output affected? The output will be inverted. Nanti you try tau, tengok macam mana. So ini adalah actually not to say definition lah, tapi bila orang mention perkataan tu, apa yang you perlu faham. When people mention inverter, it's something that input dan outputnya adalah opposite of it. Okay? Okay. When people mention truth table, what is it that you need to understand? It's actually showing the relationship of the input and the outputs. Okay, the logic circuit punya relationship. When we say timing diagram, apa yang kena faham is actually the waveforms yang saya tunjuk tadi, yang showing the proper relationships of inputs and output again. When people say Boolean algebra, what does it mean? It's the mathematics of logic gates yang kita akan tengok lepas ni. AND gate, apa yang you perlu faham adalah gate yang akan hanya high outputnya bila semua inputnya high. Okay? When people say OR gate, what do you need to know? Asalkan salah satu, input satu, outputnya adalah satu. When people say NAND gate, what you should understand, okay, dia akan jadi low bila semua input adalah high. Dia akan hanya ada satu low, iaitu bila semua input high. Dia terbalik daripada AND gate. When people say NOR gate, what you should know is actually gate yang akan dapat low output bila semua input high. Okay, those are the things yang you start ask yourself. Do you understand when people say all these key terms? Okay, when people say exclusive OR, what you should know is actually a logic gates yang produce high bila input tak sama nilai. Maknanya masa bila input tak sama nilai, sama ada 01 atau 10. Okay, itu exclusive OR. Okay, when people say exclusive NOR adalah yang menghasilkan output low bila input sama nilai, tak sama nilai, atau lagi satu caranya adalah XOR ni output logic yang menghasilkan logic gates yang menghasilkan output 1 bila input sama nilai. So bila input sama nilai, bila 220 atau 221. So key terms ni you start asking yourself. You faham tak nak explain kat orang? Ataupun when people mention, do you understand? What is it? Okay? So these are logic symbols yang menunjukkan how gates tu, logic gates di represented dalam yang saya cakap tadi integrated circuit IC ya. So ini adalah untuk kalau you baca ini you kena tahu macam mana nak baca, orang panggil pin diagram dia lah kan. Okay, selalunya dekat nombor 7 kalau it's a 14 pin diagram, nombor 7 dengan 14 ni adalah selalu untuk ground dengan VCC. VCC ni untuk hidupkan to make the IC function ya. Yeah? So kalau kat sini is actually a NAND gate. Ada 4 NAND gate dalam IC ni. Ada 4 NAND gate. So kalau you nak pakai yang pertama, macam mana you kena connect? I think you dah masuk lab lah kan. So 1, 2 adalah input, 3-nya adalah output. Okay, dan seterusnya. So kita kena faham macam mana nak pakai gate ni ya. So data sheets ya. Data sheets ni pun lagi satu yang mana kita kena tahu macam mana nak baca. Okay, kalau tak nanti you tak boleh nak buat eksperimen dan you tak boleh juga nak design circuit ya. So those are the data sheets ya that you need to understand. And selalunya dibekalkan kepada kita lah by manufacturer, atau sekarang with the internet senang je, you Google aja 7400 what are the data sheets kan. So you tahulah sebab kenapa kita nak tahu data sheet ni, sebab kita nak tengok kat mana kita nak connect tu semua ya. So yang penting selalunya VCC ni lah. VCC ni kita nak tahu mana pin groundnya, mana kita nak measure, things like that. Okay. So these are some common gates configuration when it comes to logic gates ya. 7400 adalah, saya tak suruh you hafal, tapi bila kita dah selalu guna nanti kita dah tahulah gate. Kalau NAND gate 7400 okay. Kalau selalunya kalau AND gate 7411. Tapi you tak payah hafal lah benda ni, jangan hafal. But this is just kalau inverter 7404. Those are the things. Kalau OR gate apa dia selalunya? OR gate adalah 7432 dan ada several small lah kan. Ini semua yang 4 punya gates lah, combination of gates ya. Okay. So ini adalah example okay. Street light system. So street light system ni dia bagi syarat kat sini, switch kalau on is represented by 1. Kalau off 0, okay, kalau light sensor dia dark maknanya is a 0. Kalau bright is a 1. Kalau street light to on is a 1, okay, and kalau off is a 0. Okay, these are the conditions. So disuruh kita develop the truth table of it. So mana truth table-nya? Tak ada. Okay, tak apa. So truth table-nya di sini, okay, dan this is how actually the street light punya function. Sebab dia kita nak kalau you pakai sini ya, dark 0, you kena invert dulu, ya. Then it goes to an OR gate, barulah kita akan dapat this one, street light seperti yang kita nak tu, ya. Okay. So I would like to share with you sikit lah apa kelebihan dan limitation logic gates ni, kan? Everything that we design is not going to solve all the world's problem, yeah. But it has some small limitation, but that's where actually you can actually consider how your design later on, ya. Tapi dia bukanlah dari segi fungsinya, ya, dari segi operating voltage limitnya, time delay sometimes, especially kalau untuk flip flop tau. Kita flip flop tu kan, nanti itu time delay tu you kena tengok lah. So the advantages of ataupun you know the advantages of logic gates adalah it can perform logical operation as like what kita dah tengok, and then nanti kita akan tengok Boolean algebra lepas ni. That's where actually we can use it to design circuits, yeah, dan how the simplification can be done so that we can optimize the design, yeah. So logic 1 and 0 ni memang ada dalam kita punya everyday life. Okay, kalau you tengok ya, banyak sebenarnya. So that's how it is being designed and for it to function, okay, dalam kita punya daily life. Okay, so I am done with logic gates. Any questions on that before we proceed with Boolean algebra? Ni nak tengok macam mana student ni. Ya, I stop sharing dulu, nak tengok muka you. So macam mana students? Anything that you wish to tanya dulu sebelum kita masuk ke Boolean algebra? I hope you are with me. Please, you know, I was made to understand that your exam is somewhere in 3rd week November, inshallah. So utilize these 3 sessions. This is our first session. We're going to have another 2 sessions. Utilize these 3 sessions that maybe I can, you know, we can ask questions and you can understand more, things like that. So far so good, everyone. Mana student?
Ada pertanyaan ini ditawari, kalau ada yang nggak paham silakan.
Ataupun mungkin mau tanya something else. I don't think there are any questions, ma'am. Thank you. Okay, I will proceed.
Okay, Mardani.
Thank you. Okay. I'll proceed with Boolean algebra where we are going to see ada yang dalam kita punya apa ni yang saya tanya which topics, ada yang kata they want to know more about Boolean algebra. So boleh ni ya, yang tadi saya ada throw mentimeter tu kan. Okay, we'll proceed with Boolean algebra. 1 minute. Okay. The next one is Boolean algebra. So you might be asking, okay, kat mana nak guna Boolean algebra ni, and why do we need to use Boolean algebra? Because the 7th gate that we have experienced just now is not going to actually do many things. It can do certain things, yeah, but it could not do many things because normally we have several situations that we need to consider in a design, ya. Masa ini kita nak dia buat apa? Masa ni kita nak dia control apa? Those are the things that we want. So dia tak akan banyak sangat dapat buat, ya. So we need to actually put all the conditions, dan daripada situ kita simplify. So bila kita nak ada simplification tu, kita mahu ada satu kaedah yang kita boleh gunakan on how we can optimize. Why do we want to optimize? Always ask that. Because we want to optimize the number of gates being used so that our design tu kecil. Kan? Kita kalau boleh lebih pack, lebih compact, lagi bagus lah. Because that all involves actually money. When it comes to producing things, kan kita nak sangat optimize dan sangat economical lah kita kata. Design kita tu yang paling optimize ya. Yang paling economical, because any additional gates, any additional components, resistors semua tu satu size-nya besar, bulky, we don't want that. Okay, we want it to be as compact as possible. Another thing is actually the cost. Okay, so Boolean addition. So in Boolean algebra kita dah tengok dah tadi, a variable adalah simbol, okay, untuk represent sama ada satu atau kosong, dan complement adalah inputs yang opposite of the output ya. So when it comes to add, remember ya, bila kita add tu it's OR gate. Kita kena ingat selalu kat situ ya. So dan bar tu adalah opposite of OR. Seterusnya multiplication pula, basicnya adalah AND operation. So anything yang bar of AND gate tu adalah boleh digunakan sama ada inverter ataupun NAND gate ya. Okay, commutative. The third one adalah Boolean algebra ni, dia ada law dia lah. Dia ada macam some rules yang kita kena understand fundamental dulu. So commutative law ni pula adalah untuk kita apply masa kita handles addition or multiplications ya. So dia begini. A or B adalah sama dengan B or A. So tak ada mana satu yang priority. Sorry. Dia adalah sama. A or B is equal to B or A. Seterusnya, A and B adalah bersamaan dengan B and A. So you tulis A and B and C, A and C and B, A, C and B and A, sama. It's the same meaning. Tapi selalunya lebih molek lah. It's better for us to write A and B and C. Okay? Seterusnya, associative law, maknanya bila ada bracket and it's OR, it's adding, sama je. A or B or C sama ada B or C dalam bracket atau A or B dalam bracket. Because this is OR gate, ya, ataupun OR. Similarly, kalau untuk AND, A and B and C, if we bracket the BC, sama juga weightage-nya dengan A and B being bracketed and C. Okay? And here, ini you kena tahu. Sekejap This is distributive law. Tapi you tak payah, nama-nama ni semua you tak payah hafal lah. You tak payah tahu. You kena faham yang dalam bracket ni. Okay? So A and B or A and C kita boleh common kan sebab ada dua-dua A. So kita boleh letak A dalam bracket B or C. So ianya sama. Dan ini adalah step-steps yang kita akan guna untuk simplification kelak. Ya? Okay. So dari segi gates, macam mana kita nak buat? Okay. So kalau kita tengok A and B or A and C, dari equation ni kita tahu ini memerlukan AND gate, lepas tu dua-dua kita masukkan dalam OR gate, which is this. Okay, bila kita dah simplify, we know that we need satu AND gate di sini sebab ada dot. We need satu AND gate yang akan masuk A dan sini akan represent by OR gate. So that's how kita dapat sini A and dalam bracket B or C. OR gate for the B or C, and then B or C masuk ke AND gate and A. So dari sini you boleh tengok daripada tiga gates ya, asal bila kita simplify guna this rule, this distributive law, okay, rule, kita akan dapat 2 gates. Okay, so that's how simplification is actually vital ya, penting. Dalam salah satunya adalah simplification using Boolean algebra ya, adalah penting untuk kita optimize the number of gates. Okay, so saya dah bagi tahu tadi why kita need to optimize. Of course, economical, costing, dan juga kita nak design to compact ya. Okay, so rules of Boolean algebra ada di sini. I'm not going to read one by one. I rasa okay. So A or 0 will give us A. Okay, so kalau 1 or 0, kita dapat 1 lah. Okay, A or 1 will give 1. 1 or anything is 1. You kena ingat, senang je nak ingat. 1 or anything is 1. A and 0 will give a 0. So anything, okay, n kan dengan 0 will give a 0. Okay, A and 1 will also give us 1. Okay, A or A will give us A. Dia tak ada 2A, 3A, ya. Dia 1A je. A or A is A. A or 1 is 1. Okay, A or A bar will give us 1. Okay, A and A will give us A. A and A bar, because ini akan jadi salah satu ni kosong, will give us 0. A bar 2 kali invert will give us yang asal balik. Remember kalau kita ada 1, masuk first inverter 0, masuk second inverter dia dapat 1. 1 invert dapat 0, 0 invert dapat balik 1. So kalau 2 kali invert, A bar will give us A. Okay, so ini semua adalah rule yang kita akan tengok. Selain, okay, lagi satu, A or A bar, A or A and B will give us A, because bila kita keluarkan A ni, you akan dapat dalam bracket 1 or B. Okay, 1 or B will give us 1. So A and 1 will give us A. Okay, so A and A bar will give us A or bar. Okay, and ini memang kena expand lah. This one you can do. Bila you expand, you akan dapat A or B, C. So these are Boolean algebra. Okay, so untuk yang rule 12 tu, sekejap rule 12 ni, saya akan tunjukkan di sini. Okay, A or B bracket, N kan dengan A or C bracket, kita akan dapat A or B, C. Okay, so when we expand, we will get this. Okay, saya insyaAllah semua dah faham kan? Okay, we will get all the 4 terms. And A is A. A, C, A, B, B, C. Kita dapat macam tu ya. Keluarkan A, kita akan dapat 1 or C or B plus B, C. Remember, 1 or anything is 1. So, akan tinggal A and 1 or B, C. So, dia akan dapat sebagai A or B, C. That's how simplification punya help us to actually optimize kita punya design. Okay. In addition to the 12 rules, ya, kita ada 12 rules ni. In addition to that, we have one more, which is the De Morgan theorems. So dia ada 2 theorem. Okay, so kita ada 12 plus 2, kita ada 14. So what is De Morgan theorems? De Morgan theorems, you ingat saya selalu nak student-student ni bertanya, kenapa nak kena pakai De Morgan? Kalau tak nak pakai, apa jadi? You have to ask yourself. Without De Morgan's theorem, De Morgan ni nama apa ni, the person that actually invented the theorems, you know, those people you know, yang dulu yang theoremnya kita pakai beratus-ratus tahun ni, because dia nak penambahbaikan dalam dunia masa tu ya, nak design logic circuit, nak optimize semua, so they do this all fundamental punya findings sampai hari ini kita menggunakannya. So the De Morgan theorems by the name of the person, sampai kekal kan, kalau you dapat buat theorem nanti pakai nama you lah. Saya tak dapat buat theorem lagi tu sebab tak ada nama Nooritawati theorem, saya tak dapat lagi. Okay, so De Morgan theorem ni, kalau kita tak ada theorem ni, kita punya circuit analysis akan terbantut. Sebab bila kita ada A and B bar, kita tak boleh macam mana nak pecahkan dia untuk kita proceed dengan analysis. Okay, so with De Morgan theorem that says A and B bar is equal to A bar or B bar. Maknanya di-splitkan di sini dengan OR. Okay, when we have a long bar dekat atas, it can be split as such. Okay, dan one more dia kata, how dia prove yang itu adalah A and B bar, which is an NAND gate, minta maaf, NAND gate, ataupun A bar or B bar. Maknanya kita invert dulu, baru kita masuk OR gate. So you invert dulu, baru you masuk OR gate. Kalau you tengok truth table-nya, ia akan memberi output yang sama. Okay, dia ada 2 input. Ingat, kalau 2, kita ada 4 possible combination, 0, 1, 2, 3. Dan bila kita check jawapan, outputnya, output levelnya adalah sama. Okay, so it's proven that, pandai kan De Morgan kan? A and B bar bersamaan dengan A bar or B bar. Okay. So, you boleh terima kan? Kenapa sama? Sebab outputnya adalah sama di sini. Okay. And one more, dia ada lagi satu theorem yang dia kata, kalau A or B, the long bar complement, it can be break daripada O jadi N, which is A bar and B bar. So, macam mana De Morgan buktikan? Okay. De Morgan kata satu adalah dari, minta maaf, daripada circuit. This is actually NOR gate, ya. Or dulu, A or B, and then bar kan. So, it's a NOR gate. Dan sini adalah invert dulu. Invert A, invert B, dua-dua masuk dalam AND gate. Okay. How dia provekan? Adalah dari segi sama juga outputnya. Bila dia buktikan, output adalah sama untuk A or B bar, which is sama dengan A bar and B bar. So, bila kita buat simplification, kita memang ada kala banyak kali lah nanti kita perlu break the bar here. Or else we cannot solve. Okay, we cannot solve. So, that's how actually kita akan gunakan this De Morgan theorem nanti when we simplify the equations in our design. Okay? Okay. I want you to try to get what is X now. Cuba students. Come, I give you 2 minutes. What is the answer? Cuba buat sekarang, mana student saya ni? 70 orang ada ni. Okay, macam mana? Ada yang dapat? Sekejap ya, saya stop share. Sebab kalau share saya tak nampak muka you. Sekejap. Any of you manage to get the answer? Sekejap. Mana ini? Ada satu answer bagi kat situ dah. A bar plus B bar, C or D. Okay, I'll share with you the answer. 1 minute. Mana tadi? 1 minute ya. Okay, kita akan dapat ini adalah A or B bar, which is NOR gate. Okay, this is AND gate. Okay, C ni AND gate C, lepas tu kita bawa yang sini ke sini, lepas tu X adalah X is C of this and ni OR kan dengan D. So apply De Morgan's theorem untuk to simplify this adalah we can break this, ini akan jadi A bar and B bar sini plus D. Okay, sorry, or D, and then you akan dapat A bar, B bar, C or D. Okay, good. Siapa yang dapat jawapan betul? Congratulations. Yeah, this is very basic. Okay, so okay, itu satu. Yeah, remember we have 12 Boolean algebra and 2 De Morgans. We have 14. Okay, in addition to that, kita ada sum of product and product of sum. Okay, so ask yourself, what is this? What? Apa maksud sum of product? Apa maksud product of sum? What is it actually telling us? What are the difference between these two? Why do we need to know what is sum of product or product of sum? Okay, so sum of product adalah bagaimana equation itu ditulis. Okay, so bila you tengok equation, you tahu, oh, this is sum of product. So daripada nama dia tu, ia adalah, okay, sum of several product. Product tu is actually representing by n ataupun multiplication, dan all these terms are being sum ataupun ada or di situ. So satu contoh sum of product adalah sini. These are the first product, this is the second product because dia ada n dan it is being sum. Ini lagi satu contoh sum of product. Okay, this is also sum of product. Okay, so kita akan tengok ni nanti ataupun you akan jumpa nanti bila you buat programmable logic, ya, programmable logic punya ni circuits. You akan tengok all this POS dengan SOP lah in your design, ya. Okay, that is sum of product. So product of sum adalah terbalik daripada tu lah. Product of sum, you have several sum punya variables which is being n, which is the n kan. So contoh, this is product of sum. Sini adalah sum dia, it is being n. Ini pun contoh product of sum. Ini adalah juga product of sum. Okay, so from the name, okay, and when you see, okay, you kena tahulah, oh ini SOP. Kita akan cakap, bila kita dah faham, kita akan cakap SOP lah, sum of product. Oh, this is POS yang bawah ni. This is POS. So bila you tahu terms tu, you tengok equation, you can say it. Sebab because when people mention sum of product, you have to settle, you have to write in terms of sum of product. Kalau you tak faham apa sum of product, apa you nak tulis? Kan? So we need to understand the terms. So how do we understand the terms is by looking at the equations. Okay? Okay, so sum of product ada lagi satu. Sum of product standard form. Apa yang membezakan sum of product dengan sum of product standard form? Okay? Kat mana bezanya? Okay, so if you want to know this, sum of product and sum of product standard form, sum of product standard form adalah kalau equations tu ada 3 variable, dalam produk tu ada ketiga-tiga variable. Tak kisah sama ada dia adalah inverted ataupun asal, ya. So kita boleh actually kembangkan untuk dia menjadi sum of product. Okay, standard sum of product. Okay, the first one adalah sum of product. Okay, tetapi minta maaf, ni soalan asal. Sorry. Ni soalan asal. Ini adalah sum of product, tapi dia bukan standard. Kenapa dia bukan standard? Sebab dia tak ada C kat sini. Dia ada A bar and B bar. Tapi di sini ada A, B, C. So macam mana kita nak cari satu equation, nak menjadikan one equation, the normal SOP to become a standard SOP? We can expand. Okay, so how do we expand? Remember, bagaimana dekat sini adalah like 1. Okay, so it's actually C or C bar lah. So kita masukkan C or C bar dan kita expand. So ianya akan menjadi 3 produk yang kita boleh jadikan sebagai standard SOP. Sebab dia ada A, ada B, ada C. Okay, dan ini adalah standard SOP. Standard SOP, remember, setiap produk tu ada ketiga-tiga, ada all the 3 variables. This is SOP, yang asal ni, this is SOP, but it's not a standard SOP. So when people talk to you, okay, what is standard SOP? You need to terus faham, standard SOP dalam, kalau ianya adalah 3 variables, all 3 variables need to be in that product. So this is SOP. This is standard SOP. Okay, so you dah tahu ya. And similarly, standard POS, product of sum. Again, ketiga-tiga variable needs to be in the sum before it is n kan, ya. So ini adalah POS, product of sum. Okay, tetapi ia bukan a standard POS sebab sini tak ada C dan sini tak ada B. Okay, so how do we expand it? Okay, contoh dibagi kat sini lah. We don't have C here. We don't have. This is fine because we have A or B or C. So we need to have C there for it to become the standard POS. So how do we do it? Again, from the Boolean algebra, okay. Kita akan add C bar dengan C and expand the result using rule 12 tu. So sini kita akan tengok A or B or C. Okay, sebab C ni dan you expand kan, okay, you akan dapat all the standard POS. Itu bagaimana kita expand normal, a POS, a product of sum to become a standard POS. Guna rule 12. Kalau SOP kita guna rule yang 1 ni tadi ya. C yang menjadikan dia satu. Okay. Okay, this is summarization the 12 rules, okay, and di Morgan. So kita ada 14. Okay, ada short quiz di situ. Saya nak semua tolong buat sekejap. Saya nak pergi ladies sekejap ya. You cuba buat short quiz ni. Saya pergi ladies sekejap. Okay, cuba buat dulu. Ke ada yang dah dapat? Boleh share jawapan. Sekejap saya stop share ya. Ada yang dah try? Saya nak minum air sikit. Okay, the first one, anybody can share with us? Maybe you can type at the chat box. 1 minute, I'll share back my slides. Sebentar ya. Okay, that's the answer. Ada siapa yang tak dapat? For the first and the second. So, ada yang tak dapat kelas? Ke everything? Sekejap Okay, everyone okay? Nanti next week, bukan next week, our next session will be on the 1st of November. I'm going to give you a pop quiz, yeah? An online quiz so that you can respond, and I will pass it to your professor the results. Okay, saya sambung, ya. Nanti maybe later you can ask me more, insyaAllah. Okay, so we have seen Boolean algebra, De Morgan, what is SOP, what is product of sum, what is standard sum of product, what is standard product of sum. Okay. Ini pun I have actually share with you, ya. Nanti you boleh tengok yang ni. So bagaimana? So how the next one? We have learned all the rules, we have learned all the terms. The next one, like what I said, the ultimate aim, ya, tujuan. The ultimate aim that we learn. Again, ask yourself, why do I need to learn the rules? What it's going to do, ya? So the ultimate aim adalah untuk it can actually bantu kita, assist us to do the analysis, because we want to do minimization and simplification of logic of expressions when we design something. So ada dua cara kita boleh buat simplification. Satu, using Boolean algebra, saya dah cakap tadi. The next one adalah K-map. Okay? So, sekejap, mana dia? Okay. So here, in sum of product dekat sini, ya. Ini gambar-gambar sum of product. Okay. So combinational logic circuit di sini ditunjukkan di situ, ya. So the SOP expression is actually in an AND OR combination, ya, dengan complement. So kita dapat macam tu. I think yang ini semua insya-Allah dah tahu dah. Okay. And here what is actually product of sum. Okay, and it needs to utilize De Morgan theorem sebab ia ada the long bar here, because kalau kita tak guna De Morgan theorem, we will not be able to actually solve these equations. Okay, so we use the first De Morgan theorem. Okay, so it becomes the OR becomes N, and then kita guna the second De Morgan theorem di sini, or else because sini ada kan the big bar sini for us to settle that. Okay, and then only we get the last answer, which is in the term of product of sum. Okay, this is untuk exclusive OR, yeah, the symbols, the distinct shape yang outline dekat luar tu, and this is exclusive NOR, yeah. Ini I think you tahulah. Okay, so ini adalah example for each circuit. Determine if the LED should be on or off. Okay, maybe you can, apa sahaja saya punya C tu. Alamak, sudah dapat jawapan. Tak apa. Saya nak tunjuk saya punya C tu. Okay, maybe I'll give you 2 minutes for you to settle this. Cuba tengok. Circuit tu patut on ke off? Cuba. Okay, there's one chat here. On, off, off. Lanang. Okay, thank you for answering. On, off, off. Yang lain? Saya bagi lagi 30 seconds, 30 saat. A on, okay. Lagi. B on. C off. Muhammad Umar. Very good. Okay, so I'll share with you the answer. Okay, the solution adalah yes, betul, A on. Ada satu lagi jawapan dekat chat. on, off juga dari muhtar ya. Okay. Bagus. Semua faham. Very good. Well done. So the answer is A on, B on sebab it's an XOR gate. Inputs dia agree. Okay. Maknanya seperti sini dia low. Output is low. So LED is on. Okay. The second one XNOR juga. Input disagree. Okay. Tak sama. Output is low, LED on. And the third one, why is it not doing? Okay. XOR inputs disagree. XOR dia sebab tak sama lah. Disagree itu maksud tak sama. Satu high, satu low. Output is high. So LED is off. So the answer everyone is the first one on, the second one on, the third one off. Okay. Okay. Bagus. Yang lain-lain yang tu nanti semak ya. Okay. So kita proceed with the next one is implementing combinational logic. So from the word combinational logic, which means we are going to combine these logic gates ya with one another ikut kesesuaian ya untuk SOP dan sebagainya. So this example actually show the circuit that will implement the Boolean expression. Kita diberi the Boolean expressions and we are requested to come up with the logic gates, the combinational logic gates. So kita tahu di sini we need to OR it. Kita perlu OR kan, ya, menggunakan OR gate, dan this is actually can be performed using AND gate, yeah, 3 AND gates, yeah, and which is going to be OR, dan kita akan dapat. This is very simple. I think you dah tahu yang ni. Okay, so untuk sum of product dan min term, okay, another name for sum of product adalah min term. So min term ni macam mana kita nak represent dia? Maknanya kita akan tengok dulu apa output dia, ya, output kita punya ni daripada equations tu. Daripada equations ini kita dapatkan output. So min term adalah untuk represent output mana yang high. Kalau untuk SOP kita katakan min term. Kalau product of sum, POS, is called max term. So this is actually the canonical SOP form, ya, is here. Canonical tu dia standard lah, ya. So kalau kita kata apa canonical, samalah maknanya dengan standard SOP. What is standard SOP? Which means in that each product ada all the 3 variables. Okay? And it can be written as such ataupun dalam min term. So min term di sini adalah di mana outputnya adalah high, which is at 3. Okay, 0, 1, 1 is 3, binary. We're talking about binary here, which is at 3, at 5, at 6, and at 7. Yeah. Okay. Okay, ini adalah product of sum. Okay, product of sum. So this is product of sum. Okay, and we check what is the output, and it can also be written in max term. Okay, this is to represent it is POS. And it is at 0, 1, 2, and 4. Okay, remember yang ini adalah min term, sum of min term. Okay, ni simbol ni sum of min term. And we are extracting, kita extract all the ones because this is sum of product, ya. So it has dia high dekat 3, 5, 6, 7. So bila kita tahu min term ni, so when we are given min term, what should we know? Okay, if we are given min term, kita dah tahu min term actually represent output yang high bila inputnya adalah dekat apa berlaku dalam min term tu yang diberitahu. So sini bila kita diberi min term ni, we know that for these for these logic gates, okay, the output is high at combination of 3, 5, 6, 7. Selainnya output dia adalah low. So bila kita dapat min term, we can actually reversekan balik, produce the truth table, and we can write the equation, okay, and design the circuit. Kita boleh go which way? Maknanya banyak maklumat, daripada satu maklumat which is min term, we can tahu information yang lain. Okay, so max term pula, what does it tell us? Okay, here is a product of max term at 0, 1, 2, 4, which means at 0, 1, 2, 4 ianya adalah 0, selainnya dia adalah 1. So bila kita diberitahu max term, satu kita tahu dia adalah POS. Itu you kena ingat. Kalau kita diberi min term, we know it is a sum of product. And from the min term, it is telling us at what output it is 1. It is high. So the rest information kita boleh dapat lah. Similarly here, we know when we are given product of sum, okay, so we know it's already product of sum, and 0, 1, 2, 0, 1, 2, and 4. So it's telling us at these 4 conditions of inputs, outputnya adalah kosong. So selainnya output adalah high. Okay? Okay, so selain daripada tu ada 2 daripada 7 gates yang kita belajar tu, ingat XOR, XNOR adalah eksklusif. So tinggal 5. 5 ni ada 2 gates yang dikenali sebagai universal gate. Ataupun why kita panggil universal? Because it is as such that these gates, okay, NAND dengan NOR, kita akan tengok nanti, can represent the other gates. Dia boleh NAND boleh jadi AND, NAND boleh jadi OR, NAND boleh jadi inverter, NAND boleh jadi NOR, dan NAND juga boleh jadi NAND memang boleh jadi NAND lah kan. So dia boleh represent yang lain. Okay, it can represent. That's why we call it universal. Okay, so ada 2 gates yang begitu. So NAND gates are sometimes called universal gate because they can be used to produce the other basic Boolean functions. Yeah. So ingat tak tadi? Dia kalau nak jadi inverter, combinekan inputnya sebagai satu, it becomes an inverter. For it to become AND gate, okay, the output of the first NAND gate masuk dalam inverter. So dia akan jadi AND gate. For it to become OR gate, okay, invertkan dahulu inputs dan masuk dalam NAND gate. It becomes OR gate. For it to become NOR gates, ya, begini. Dia macam OR gate tapi invert. Nampak tak? Senang kan? Dia macam OR gate, kita invertkan. Okay, so NAND jadi NAND tak payah tunjuk lah. That is NAND gate. Another universal gates adalah NOR gate. 2 gate ni. Okay, ingat kita ada 7. 2 XOR gate, 2 XOR dengan XNOR. 5 ni NAND dengan NOR. Is also known as universal. So, apa maksud universal? Gate ini boleh, these 2 gates can be used to represent gate-gate yang lain. Macam yang tadi. So sekarang kita tengok NOR gate pula. Macam mana NOR gate represent inverter? Commonkan inputnya. Dia sama juga macam NAND gate tadi. Commonkan input, dia akan jadi inverter. Untuk dia jadi OR, okay, the first NOR masukkan dalam inverter. Untuk ianya menjadi AND, okay, invert dulu masuk dalam NOR gate. Dan untuk dia menjadi NAND, sama macam ni, sebab ni dah AND, invertkan, dapat NAND. Okay, so that is how NAND and NOR is also known as universal gates because it can be used to represent other gates. So kalau kat sini, selain dia sebagai NOR gates, it can be used to represent inverter, OR gate, AND gate, and NAND gate. And salah sini. Dan untuk NAND gate, selain ianya sebagai NAND gate, it can represent inverter, AND gate, OR gate, and NOR gate. Okay, so 2 gate ni dinamakan sebagai universal gates. Okay, okay, this is the one. Dah bagi jawapan pula, tak apalah. Untuk can you try whether you get the answer or not? Okay, so tak apa, this one simple one. A and B ni kita akan sama ada A and B sama dengan A bar or B bar. Okay, ini daripada one of the De Morgan theorem. So what you need to do here is to get actually the equations and only then you can simplify. Okay, using De Morgan. Okay, so dia kata kat sini lagi satu cara. Kalau you jumpa bubble dengan bubble, you cancel. Itu pun boleh juga. Tapi kalau you not sure, you kena practice banyak kali and try to, not to say try, practice banyak kali and tell yourself that you really understand, then only you do it. Dia kena bubble baru boleh cancel. Jangan bubble, ada something bubble, tu jangan cancel. Sebab kadang-kadang student kan, bubble dia bukan terus tau. It's connecting from bubble to bubble. Dia ada something gate, dia dah cancel. You cannot do that. It's only can be done if you have dalam satu connection tu 2 bubble. Yes, you can do. Okay, you cancel it, then tu. Tapi kalau you tak sure, you better not. Nanti takut it leads to mistakes, ya. Sama juga di sini. The bubble here you can cancel, and you will get that. Of course, using the Morgan theorem lah dulu kan, sebab you need to break this one kan. Okay, pulse waveform ni sama juga. Instead of yang tu, okay, kita tengok pulse waveformnya dan you draw lah ya. Ini satu cara lagi. Sorry. Dan daripada pulse waveform tu, you akan dapat the output lah untuk G3. Okay. Sekejap. Okay, cuba buat yang ni. Sorry. This is the question. Tak apa, ini quiz nanti ya. Ini quiz nanti tak apa untuk you cuba. So what time is it now? Okay, we have a few more minutes ya. Kita pergi kepada K-map, Carnot map. Okay, sebelum tu, I just want to see the students. Okay, so anything on your part before we go to Carnot map? Kita dah banyak juga dah ni. Ya, kita dah tengok simplification, cuma kita belum settle, belum quiz tu tak apalah, nanti you boleh try ni. Okay. Saya akan bagi you can try later on. So everyone good ya, insyaAllah? So that we can go to K-map. So saya akan proceed dengan K-map. Okay. Saya belum share slide. Sebentar ya. Okay, remember kita dah tengok basic logic gates mula-mula tadi ya. And kita dah juga tengok the 12 theorems of Boolean algebra and the De Morgan, SOP, POS, min term, max term, universality of gates ya, among all the 7 gates, excluding bila kita the exclusive or the universality adalah NAND gate and NOR gate. So apa maksud universality ni atau universal gates adalah ianya boleh juga represent the other logic gates, seperti yang telah ditunjukkan. And then kita dah tengok bagaimana kita nak melaksanakan simplifications using Boolean algebra ya. Okay. One of the way, okay, and De Morgan's is normally De Morgan's is required lah sebab to break the bar tu kan. Okay, another way, another way on how we can actually handle simplification is using Carnot map, Carnot map ataupun short form dia bila kita dah selalu sebut kita panggil K-map saja. Okay, so kalau tadi Boolean algebra is from the equation, okay, based on the rules, yeah, the simplification rules. K-map, this is actually a map that represent secara diagram, ya, ataupun pictorial the relationship between inputs and output as well. So bila kita buat simplification, you have to choose either one. Is it going to be Boolean or K-map? Dia tak boleh campur. You tak boleh halfway you buat Boolean, lepas tu you masuk K-map. Tak boleh. If it's going to be Boolean, finish everything sampai dapat the simplified version, answer menggunakan Boolean. If it's going to be K-map, okay, put dalam map to everything, loop. Okay, there are the rules of looping too, which we will share later on using K-map solely. There are two ways. You choose which one, cannot be mixed. You can start with one, sampai siap, dapat jawapan everything, design. Similarly untuk K-map juga. Okay? So here K-map, you can read on your own kat situ, dia kata, so it's actually a special version of truth table. Why? Sebab dari K-map tu kita tahu what is the relationship of input and output. What do we mean by relationship here? Is actually each cell, okay, is represented by the value, and dalam sel tu diletakkan sama ada kosong atau satu yang memberitahu kita output ketika itu, which is either 0 or 1, and kita guna looping technique on how to simplify, and what are the rules of the looping technique, kita akan tengok di sini. Okay, so here using K-map, okay, expressions with 2 to 4 variables are easily minimized. Kalau lebih daripada 4, 2 ganda 5 is 32, we need to use 2 K-map. Macam tu. Tak adalah, tak boleh. Ya, boleh. Okay, tapi yalah lagi kena extra careful lah. We want to be extra careful so that we won't make mistakes, yeah. We won't make errors. Okay. So expression with 5 to 6 variables are more challenging, but can be done, yeah. Tapi selalunya 2 to 4. So when it says an variable of K-map, what does it mean? Which means kalau ada 2 input, K-map tu akan ada 4 cells. 4 cells tu size K-map tu lah, ya. Kalau ada 3 variables, K-map tu akan ada 8 cells. 2 kali 3, 8. Okay, so K-map cells ni will be labeled corresponding dengan truth table punya setiap row, ya. Okay, so and then yang kita kena be careful dengan K-map ni, and is the rule of the K-map. Okay, this one you don't ask me why, because that's the rule. How does the rule comes in? Maybe when they design the K-map too, yeah, they find that this is actually the must do. We have to follow the rule. Ada certain things that, you know, we just have to follow the rules, or else we cannot use the theorem. Macam tu lah. So K-map cells are arranged such that you kena tengok ayat kat sini. I think I kena bold kat sini, ataupun mungkin you dah tahu, but I will just put it in red color. Such that adjacent cells, okay, correspond to truth rows that differ in only 1 bit position. Maknanya kalau kita ada 4 kalau untuk 2 input, ya, untuk 2 input, kita tahu input variables dia adalah 0, 1, 2, 3 kan, which is 0, 0, 0, 1, 1, 0, 1, 1. Tetapi bila kita susun kat K-map, nanti you akan tengok, ataupun you pun mungkin dah experience, kita susun macam mana? 0, 0, 0, 1, lepas tu kita susun 1, 1, baru 1, 0. Sebab dia punya rule, daripada satu sel ke satu sel, hanya 1 bit boleh berubah. 0, 0 akan jadi 0, 1. Kalau lepas 0, 1 dia jadi 1, 0, 2 bit berubah daripada 01 ke 10. That's where 1, 1 comes in dulu. So 0, 1 to 1, 1, then only 1, 1 to 1, 0. Itu memang rule dia. Okay. So why do we actually use simplification? How we use simplification guidelines untuk K-map? So always combine many cells yang ada large group of 1. Okay. Okay, so bagaimana? Dia boleh start dengan yang paling besar. Maknanya 2 to the power of 4, which is 16, 2 to the power of 3 group of 8, 2 to the power of 2 group of 4, 2 to the power of 1 group of 2, and isolated 1. So K-map ni, kalau untuk SOP, standard of product, kita kena loop semua satu. Kalau dia tak boleh nak jadi group of 3, group of 2, group of 1, itu kita panggil isolated one. Tapi syarat dia, all satu kena masuk group, kena digroupkan. Okay, dan selalu always begin with the largest group of 1. Okay, here. Okay, this is map. So if we have 3 variables, 2 ganda 3, kita akan ada 8 cells. Ini yang kita panggil cells ni. Okay, cells dia. So remember I said to you, dia akan jadi apa? 000, 11, 000, 010. Ini dia boleh berubah satu je. Dia tak tulis pula kat sini ya. Saya punya yang ni nanti kita tengok. Here. Okay, this is better. Cells are usually labeled using 0 and 1 to represent the variable and its component. So kalau 2 ganda 3, 3 variables, we will have 8 cells. So you can use either A, B or C. Ada tak saya tunjuk lagi satu? Saya tunjuk satu dulu tak apa. Ataupun A, B, C pun boleh. Dia pusing the other way. Mana-mana pun boleh. Bukanlah kena macam ni. Sebab kalau 8 ni, it can be horizontal as well. Which is betul maknanya A, B, C belah sana. Ya. Ini you tengok kat sini. 0, 1. Okay, ni tak apalah. Ini 0, 0, 0, 1, 1, 1, 1, 0. Ini yang kata only one value can differ, yeah, between one cell to another. So kalau kita tengok dekat sini, from 0, 0 to 0, 1, cell ni berubah. Okay, from 0, 1, kalau kita letak 1, 0 sini, 0, 1 letak 1, 0, dua-dua akan berubah, which is tak boleh dalam K-map. That is why it is designed in such a way, dalam K-map, lepas 0, 1 adalah 1, 1, which means cell ni berubah. Yang ini masih sama. Okay, dan untuk 1, 1 ke 1, 0, bit ni sama, yang ini berubah. Sebab syarat dia, remember tadi, sini, syarat dia, adjacent cells correspond to truth rows that differ in only one bit position. Hanya satu je boleh berubah. That is the rule. Ya, untuk K-map, that's why. Okay, and then untuk setiap ni, nanti ya, saya patut letak dia kat sini. Sekejap. Saya nak angkat yang ni, letak sini supaya you boleh nampak. I will put it here. Okay, yang ni biar dulu. Kalau tak nanti dia akan, you tak nampak relationship dia. Sekejap ya. I put up here. Okay, I put it side by side. So you can see better. Okay, so itu adalah how we actually label our cells. Okay, and remember I said to you that K-map ni juga adalah a way to represent the inputs versus output. Okay, so how do we read? A, B, C maknanya ini adalah 0, 0, 0. Ini masa kalau dekat truth table 0, 0, 0. Di sini adalah 0, 0, 1. Ni yang semua. Masa ni 0, 0, 1 dan seterusnya. So bila kita tahu sini adalah semasa input 0, 0, 0, 0, 0, 1, 0, 1, 0, 0, 1, 1 dan seterusnya. So dalam tu nanti kita akan masukkan the value of the outputs of each output with respect to each input punya value, combination of inputs ya. Okay. Ini I just said to you. So alternatively untuk 3 variables, ingat 2 kali 3 8 sebab dia ada 8 sel. Kita boleh sama ada buat dalam bentuk yang ini yang saya tunjuk dekat you sebelum ni ataupun this one. Ya. Horizontal kan dia. Dua-dua boleh. Okay, tak salah. Ya. And then ini saya dah tunjuk tadi. Okay, alternatively, okay, cells can be labeled with the variable letters. Sama ada you guna macam yang tadi. I think I put all 3 here so that you can see the difference. Ya, saya ambil balik ni. Mana dia? Sini. Oh, dia actually ada kat situ. Saya dah letak. Macam mana dia tak ni ya? Dia macam tak tunjuk. Sebab saya rasa saya letak dia. Sekejap Siap ada solution ni. Tak apa. Tak apa ni biar dulu. Saya nak tunjuk yang ni dulu. Ini jawapan lah. Sorry. Okey, tak apa. Sini, saya teruskan. Okey, sini. Here, sorry for that. Okay, alternatively, cells can be labeled with the variable letters. So kalau kat sini tadi kita gunakan 01 begini, 0001. Kalau you tak nak terus guna macam tu pun, you tak nak guna tu, you nak terus pakai begini. Sini dulu. 00 is actually A bar B bar, ya. C punya 0 is C bar and C. Pun boleh juga. Okay. So as an example, read the terms for the yellow cells. Ini nak bagi faham lah. So this is actually A bar, B, C bar, which is 010. Ini adalah 3. Okay. Ini adalah A, B bar, C. 101, which is kat sini adalah 5. Okay. Okay. So K-maps can simplify combinational logic by grouping cells and eliminating variables change. Okay, it's being mentioned there. Okay, so di sini kalau kita diminta untuk group on the map and read the minimum logic, macam mana? Okay, dia ingat saya kata dia kena start dengan group of with the largest group of 1. So sini kita boleh ada 2 groups of 2, dan di situ dia ada yang overlap di situ. So how do we read it is actually, okay, here. Sini kita tengok apa yang sama di sini. Okay, so yang sama 00, so ini akan jadi A bar, okay, A bar and B. Okay, di sini yang sama adalah C bar, C bar sebab 0, ya. So the horizontal group pula dibaca sebagai yang sama di sini adalah apa? A bar B, okey, dan di sini yang sama adalah apa? A bar and C bar. Apa yang sama untuk grup ni? Okey, you tengok di sini yang sama adalah A bar, A bar, okey, yang sama adalah A bar dan C bar. Yang sama untuk vertical ni. Yang horizontal yang sama adalah, ini tak sama, 1011 C dia, sini yang sama, A bar and B. So the answer is A bar, C bar or AB. That's how K-map punya cara untuk simplification. Okay. 1 minute ya, sekejap. Okay, for this one, sorry for that. For this one, we are required to simplify sum of midterm and max term. Okay, so this is how the looping is being done. Okay, kalau you tengok di sini, why is it not moving? Okay, and this is some more. Okay, itu untuk 2 variable ya. Ingat yang ini you kena ingat. Okay, untuk K-map, please remember untuk K-map, okay, kalau the ultimate solution of K-map is actually to loop in the largest group of 1, tapi dia kena ikut rules 2 to the power of n, which means group of 16 or group of 8 or group of 4 or group of 2 or isolated 1. Okay, Tetapi if that particular loop, okay, telah masuk dalam loop lain, maknanya tak ada satu pun one dia yang free being ni, therefore that particular loop needs to be omitted. Contoh di sini. Kita dah loop with the blue loops, ya, the ones. Sebab kita kadang-kadang bila kita loop kita tak ingat kan? Okay, kita loop with the ones, with the blue loop, and then kita buat yang orange dulu. Lepas kita buat orange, bila kita buat blue loop, kita buat yang orange. Lepas tu barulah kita buat yang merah. You tengok situ Kita buat yang ni, kita nak loop semua one kan? Yang possible group of two lah di sini. Okay, and kita nak buat, and then kita buat orange dulu. We don't know. Okay, sebab kita we loop kan. Lama-lama bila you dah tahu, you tahulah kan. Macam mana tak payah perlu buat yang orange tu. And then you buat the red one. Okay, bila you tengok situ, yang orange tu perlu dikeluarkan. Maknanya tak perlu. The orange one no need anymore. Why? Because without the orange, all the ones are already in a loop. Okay? So how do you check that we don't need the orange one? Is here the rule. If the loop did not contain one that is not shared. Maknanya yang blue ni, the one ni tak ada share dengan apa-apa. Yang merah, yang ini tak share dengan apa-apa. But the orange, both are shared with blue. This one shared with blue, this one shared with red. Therefore, the orange one is no longer required. Itu you kena be careful kalau KMAP. That's how we check for the rules. Okay? Okay, any questions? Because I think we are almost at the end, so we will continue untuk KMAP 4 cells pula lepas ni. But maybe I can open for Q&A for 5 minutes before we end our session. So I'll just stop sharing. So far so good, everyone. Is there? I'm going to nanti any questions from your part? Sekejap ya. Okay, any questions from the class? Sebelum kita, okay, I'll just share for you to answer. Maybe you are shy to say, okay. But from the Mentimeter, I have actually asked something. Do you still understand? Have you understand better or still how? Okay. Not why topic, which topic? Sorry, there's error there. Which topic, not why topic, sorry. Which topic still not, you cannot understand. Because we are here to actually to assist you. Please remember that. Okay, maybe you can respond. Class? Respond the Mentimeter. I have shared with you the link. Okay, Alhamdulillah. The rest, please do not be afraid to tell which topic that you algebra and Boolean still could not understand, is it? Still not with the Morgan. Okay, at least I know which one to actually emphasize. Okay. Some more? Okay, Alhamdulillah. The rest, we have 70 of you. Only 4 answered. What have happened to the 66? D. Morgan. Okay, good. Some more? so that I can for the next class I will focus this De Morgan to make you understand much better. Maybe I need to do it one by one. Some more? Okay, understand? De Morgan better, okay? Some more? What happened to the other of my students? Okay. How to input value K-map? Okay, good. I keep that. Some more? We want feedback so that we can actually help you. I don't even know who answered this, okay, because we want to make everybody understand. So don't worry. Lagi? So I need to actually stress more on De Morgan. Thank you for the feedback. And maybe K-map we just settle, yeah. K-map, okay, not to worry, okay, because masalah kita boleh, insyaAllah kita boleh make you understand a bit of algebra Boolean there. Okay, De Morgan, okay. Go, keep on giving your inputs. I will keep these slides so that I can prepare more examples, maybe hands-on, for you to understand more. Okay, Prof, I think that's all for today. We will actually, I will just share with the rest here, okay, the feedback that we received today. 1 minute from our students. Okay, they still want to know a bit more on De Morgan. Some on De Morgan. K-map, maybe we just begin just now. A few on K-map and only some on algebra. But De Morgan, I think I need to stress next class, inshallah, yeah? Prof, I think that's all for today. I pass back to you, Prof.
Yeah, right. Thank you, Prof. Noorita. There is a question on the chat, maybe. Excuse me, can I get your PowerPoint because I think, oh,
okay, sorry. Oh, I am fast. Okay, I will share and I will slow down next week, inshallah. Not to worry. Sorry for that.
Yeah.
I take note of that. Thank you. I am so sorry.
Yeah.
Muhta, I will slow down my face. Okay, thank you for the feedback. Okay, any more questions?
Ada pertanyaan lagi, silakan. Mungkin sudah cukup, Prof.
Okay.
Okay. Thank you, Prof. Noorita, for your time to join in this class. Mungkin kalau ada kekurangan, saya minta maaf.
Saya pun minta maaf.
See you at 1st November, maybe.
1st November, and the third one I will tell Prof. Okay, after this.
Okay.
The third class, I will give you the date.
Yeah. Jadi sampai ketemu nanti dengan Prof. Noorita lagi pada tanggal 1 November. Gitu. Saya terima kasih kepada seluruh mahasiswa, walaupun ini kelihatannya partisipannya mungkin paralel dengan kelas yang lain sehingga tidak bisa maksimal 120. Normally we have 120 student in sistem digital.
Okay.
And the schedule is on divide on 5 times. So first group and the second group until 5th group is different schedule. So they cannot join all in this class.
Oh, understand. Okay. I understand.
Oke, begitu. Terima kasih.
Thank you students.
Okay.
Thank you, Prof.
Yeah.
Insya Allah.
Oke, terima kasih.